Welcome to the DIY Honda Garage channel. Welcome to our presentation on DTC P0986, which indicates a problem with the Shift Solenoid Valve E in the 2011 to 2016 Honda CRV. This trouble code signifies that there is an open circuit relating to the shift solenoid, meaning that the electrical connection is faulty. The shift solenoid is a crucial component that helps control the transmission's shifting operations. When the solenoid is functioning properly, it allows fluid to flow within the transmission, ensuring smooth gear transitions. If it fails, it can lead to poor performance or even transmission damage. Our aim today is to provide a thorough troubleshooting guide to assist in identifying and resolving the issues tied to this DTC P0986. DTC P0986 indicates an issue with the Shift Solenoid Valve E, suggesting an open circuit condition. This code is specifically related to the electrical component rather than a mechanical problem in the transmission itself. The shift solenoid plays a pivotal role in controlling the flow of transmission fluid, thereby managing how and when the vehicle shifts gears. A malfunctioning solenoid can lead to shifting delays or erratic behaviors in the transmission. Positionally, the shift solenoid valve E is typically located within the transmission assembly, making it somewhat challenging to access for testing and repairs. This aspect adds to the complexity of diagnosing the problem effectively. The potential causes of DTC P0986 primarily revolve around electrical circuit issues. This trouble code indicates that there is an electrical problem in the circuit rather than a mechanical failure. A faulty shift solenoid valve itself can also generate this DTC, as it may have internal damage leading to an open circuit. Additionally, poor electrical connections or loose terminals can interrupt the signal necessary for the solenoid to function. Consequently, ensuring the integrity of these connections during diagnostics is crucial in resolving the code. Lastly, the problem may involve the powertrain control module, or PCM, the brain of the transmission system. Symptoms of DTC P0986 can manifest as noticeable transmission issues. Drivers may experience harsh or delayed shifts when attempting to change gears, indicating that the transmission is not operating efficiently. Such symptoms could lead to uncomfortable driving experiences, including unresponsive acceleration or slipping gears. Additionally, the check engine light will likely illuminate on the dashboard, alerting the driver that there is a diagnostic trouble code present. Recognizing these symptoms promptly can aid in troubleshooting and prevent further damage to the transmission system. Identifying these behaviors early can ultimately save time and costs associated with extensive repairs. The first step in troubleshooting DTC P0986 involves problem verification by utilizing the Honda Diagnostic System, or HDS, to ensure accurate diagnostics. Begin by turning the ignition switch to the on position. Next, clear the existing DTC using the HDS, creating a clean slate for testing. After clearing, start the engine while ensuring the transmission shift lever is in the neutral position. It is essential to allow the engine to run for at least 1 second before checking for any pending or confirmed DTCs. This verification helps confirm if the original fault still exists, aiding in the systematic approach to pinpointing the issue. If the DTC reappears, it illustrates that the problem is persistent and requires further exploration. In the second troubleshooting step, it's vital to conduct an operational check on Shift Solenoid Valve E. Access the miscellaneous test menu within the HDS and specifically select the option for Shift Solenoid Valve E. During the test, you should listen attentively for a clicking sound emanating from the solenoid. If a clicking sound is indeed heard, It signifies that the solenoid is operating correctly, enabling you to move on to the third step. However, if the sound is absent, this indicates a possible failure in the solenoid operation, necessitating further investigation and testing. This step is crucial to determining whether the solenoid is functioning as intended or if it requires replacement. The third troubleshooting step involves monitoring the onboard diagnostics, or OBD, status for the DTC P0986. Begin by restarting the engine with the shift lever still positioned in neutral. Allow the engine to run for a minimum of 1 second before navigating through the DTCs menu on the HDS system. The aim is to check if the HDS indicates failed for DTC P0986. If it does, it confirms that the issue still exists, and you will need to go back to check for loose connections between the Solenoid Valve E and the Powertrain Control Module, or PCM. If the status shows passed, however, you might be dealing with an intermittent failure or a system functioning correctly at that moment, warranting a thorough inspection of the connections to ensure secure and effective functionality. Step 4 requires performing an internal resistance check on Shift Solenoid Valve E. Begin by turning the ignition switch to the lock position. Next, use the HDS to jump the SCS line, which stands for the SRS, Supplemental Restraint System Connector. After jumping the line, disconnect the PCM Connector B, which consists of 49 pins. Utilizing a multimeter, you will measure the resistance between specific test points: the PCM Connector B pin 40, which is yellow, and the body ground. Ideally, the resistance should measure between 13.8 to 17.1 ohms. If it falls within this range, the solenoid is functioning correctly, and you may need to check if the PCM has the latest software. If outside this range, proceed to the next step for further diagnostics. In the fifth step, check for an open circuit in the shift solenoid wire harness. Start by disconnecting the 8-pin connector associated with the wire harness for the shift solenoid. Next, you must check for continuity between the test points specified. Make sure that the PCM connector B remains disconnected along with the shift solenoid wire harness, as this will affect the continuity readings. The test will use the yellow Shi wire at pin 2 of the shift solenoid wire harness connector and pin 40 on the PCM connector. If continuity is established, this ensures that the Shi wire is functioning properly. If not, it's crucial to repair any open circuits in this wire to restore proper connectivity and function. The sixth step involves checking the shift solenoid wire harness for continuity issues. First, ensure to disconnect the associated shift solenoid wire harness thoroughly before proceeding. Similar to previous tests, check continuity between designated test points comprising the shift solenoid valve E connector and the wire harness connector. The critical part of this test requires ensuring that all necessary connectors are disconnected to guarantee accurate results. It will measure continuity between the red wire at pin 1 of the shift solenoid valve E connector and the red wire at pin 1 of the 7-pin harness connector. Should continuity be confirmed, it indicates that the wire harness is functioning properly, allowing you to proceed to replace the shift solenoid valve E if the harness checks out fine. If there is no continuity, replacing the wire harness becomes the necessary step. Once all repairs have been made, it's essential to perform a final verification to ensure the issue is resolved. Start by reconnecting all previously disconnected connectors, ensuring tight and secure connections to prevent future issues. Turn the ignition switch to the on position again and proceed to clear the DTC with the HDS. After completing this step, start the engine with the shift lever in park for at least 1 second before switching to neutral. Finally, monitor the OBD status through the HDS system to see if the status indicates passed, failed, or not completed. If it indicates passed, this verifies that troubleshooting is complete, confirming the success of the repair process. If not completed or failed, it's crucial to revisit previous steps and check for any loose connections or issues that reoccurred. To prevent the recurrence of DTC P0986, incorporating routine preventive maintenance into your vehicle care is vital. Begin with establishing regular electrical checks, ensuring that all connections related to the shift solenoid and PCM remain secure and free of corrosion. Implementing software updates for the PCM will also ensure compatibility and optimized performance, thereby reducing the chances of issues arising from outdated software. Monitoring the transmission performance will allow for the detection of any early signs or symptoms, like delayed shifting or strange noises, enabling timely interventions. Adopting a proactive approach can mitigate potential failures, extending the lifespan and reliability of the vehicle's transmission system. Emphasizing preventive practices not only improves functionality, but contributes to a smoother and safer driving experience overall. In conclusion, the DTC P0986 alerts us to electrical problems related to the Shift Solenoid Valve E. Due to the role that this solenoid plays in transmission performance, understanding its function is crucial for accurate diagnostics. Thorough troubleshooting, including the 6 detailed steps outlined, enables technicians to effectively isolate the cause of the fault and apply the necessary repairs. It is important for vehicle owners to be vigilant about any symptoms related to transmission behavior and address them promptly to avoid further complications. Moreover, integrating preventive maintenance practices can significantly enhance the overall reliability and smooth operation of the transmission. This understanding equips technicians and vehicle owners alike with the knowledge to maximize the longevity and performance of their Honda CRV. Please like and subscribe to the channel. See you next time.